Hello, Anik. I was just mentioning I was giving a couple of minutes for people to start filtering in, but it seems like we've got like 19 or 20 people, and the recording has started as well. So yeah, probably going to start soon.
Thanks.
Great. Okay. Right. So hello again, everyone. Today we're going to be looking at data collection. I'm going to do a couple of notes first before we get into that. So I'm going to have to leave the call a little bit earlier. So by the time towards the end, towards the assignment, Anik is going to help me and take over for the last like 20 minutes because I need to be at another event. But yeah, we'll be giving this lecture together. I want to start off with like a quick recap from yesterday, just to like confirm. Some of you might have already seen the short sort of video where I was showcasing this, but in case you haven't, then let me quickly show. The issue that we ran into in that live demonstration yesterday for the run was fixed. Basically, there was a little typo in this dash here, which is why I didn't find the case study. But then once we have that fixed, then we have this run, and it appeared on my screen, but it will show these kinds of plots. So that's the type of ones that are linked into the alternative assignment. There's two key plots that are going to be shown as like quick results. So first is the size of the assets. So as we mentioned yesterday, that's going to be in gigawatt. And it displays like all of the assets that are listed in the environment. And you may close this graph to show the next one. And you can also save it directly into your laptop. So if I close it, it'll tell me how much things cost, which the size is in the background, but the cost appeared in my other screen. So that's basically the idea of visualize results currently like plotted in Stevens. The other values are the ones that are displayed here. So the total emissions for the system and the total cost, which will be the sum of all of those bars that you saw in the plot. So this is now up and working. With the repository, so I did get someone's message of running into some like issues with it. So just a reminder for everyone, please, if you do run into any errors or anything, like do email me. Let me know. We're figuring out the things that like might work best. And this with like open source software in different operating systems, in different laptops, everything sometimes has this you can have small bugs and issues that might not appear for some people but might appear for others, and it's really good for us and for like collaboration and development of these kinds of tools to have that feedback, the raising of issues, so that we have something that's stable moving forward and most useful for everyone. So great. Now that recap is done, we can go into the subject for our fourth lecture of the week. So we're going to be looking into data collection, as mentioned. First of all, a brief overview of best practices and what the general idea of like the templates that we'd want to see. Asset naming, so this is relating like what a real technology is in Stevens. It's going to include like a quick reminder and reference for you for the things that we have in Stevens currently. Some parameter examples. So I am going to go over into some specific sources that we can look at for specifically power sector data collection. It's going to be like techno-economic factors mostly. And this will be sort of like for you to get an idea of what the practice is, how we look for the data. Some initial sources yet, but you can look for it in different sources as well. And we're going to put the third and last assignment of the course towards the end. So it's a general thing. Quick little recap. We've been seeing sort of like that energy challenge and building blocks of energy systems, how we're turning this into a model. We're abstracting these ideas to be able to run them computationally and get some useful results. Now we're going to that really important part to get that underlying data and to find where that comes from. So first of all, best practices. Some of this might be very sort of like obvious or straightforward, but because we've been discussing this importance of the reliability of the data that we're using behind the models and how sensitive models may be to a certain parameter or a certain assumption, we can have very different effects if we use not faulty, but maybe not like as updated data, or something that's not really useful for one specific context, but yes for another. So that's like the general idea. A good data collection effort makes these assumptions and results useful, but also defensible. And something that's not like written here, very tractable, so things that you can sort of like, or traceable, sorry, that you can go and see exactly where it came from. So very proper documentation of where this data is coming from. So there's three key principles that we need to keep in mind and always forget. The first is always record the source. So for anyone who's going to come to like review the work or update the data, or figure out if there is an issue with the data input because results might be a little bit not as expected, let's say, then this is going to help them go find like, okay, it came from here, and then this other place had that data source that had these assumptions, right? Like A, B, C, D assumptions, and it turns out that those don't match with my model. So that sort of idea is really good to keep track of. With mathematical models, of course, and in energy, it's very important to always record the original unit. You're going to see a lot of cost data or efficiency data or magnitude that each model that's out there, so the examples that we've seen yesterday and everything, they might have different units themselves and reports in different units, but also different data sources might have different units, and we want to unify everything within a model so that it's relevant and comparable. And finally, to always flag uncertainty. So we've been seeing, and I've been sort of mentioning throughout the last few courses, that if we don't have a country-specific value or a more updated value or things like that, it's important to have, if we need the data for something else, at least for the purposes of this project and maybe for future projects that you might be a part of, you can use proxies or approximations, so long as this is always flagged importantly and very well documented. So just figure out what the decision of that assumption is going to be. If you have two different sources with different values that might differ a little bit, then okay, go ahead and say, I'm going to pick this one because of these three reasons. It might seem more accurate because you have expertise in where that came from, or the assumptions of the study might be more in line with what you're looking for. But it's important to always track that and flag it. Okay, so this is an example of what the template that we're going to send is going to look like. So we have these basic columns for this specific data collection exercise. There can be more like notes added depending on what the focus of your data collection will be. But for example, here to the left, we have the asset. In this case, we see, so power plant, this means natural gas, and combined cycle gas turbine that emits CO2. And we're going to be collecting the parameter sizing constant. We have the value that we saw in the literature. For example, if we find this in the report, this was reported in, dollars per kilowatt peak. But we know that Stevens units are $1 billion per gigawatt peak, so we need to convert that. So that's the Steven value. And we have an additional column for like what's the conversion that was applied. So this is to keep like very standardized and methodical documentation of where things are coming from. We have the column for source, so we have the full reference. It's important if you can to include always like the tables or the figures where the data came from. That's going to make it a lot easier for anyone who's coming to, again, like update or review, or even for you to go back and see the data, like, oh, this is where I got this value. As the number of values that you're collecting and the model grows, the amount of data that you're collecting is obviously like a lot larger. So it becomes very difficult to keep track of. If you have like a 100 pages report or 200 pages report, and you just cite the report, it's going to be like quite hard or gruesome to go looking for that specific value and find out the assumptions, etc. The next column is what the year of the data is. This is important to keep track of whether we have enoughly, like sufficiently updated data, or if we need to go and gather like more updated data for the relevance of our results. Another column, this is like quite sort of GMPA focused, because it's like whether it's a country specific or a regional approximation or another proxy that we might be considering. So that's to track like, okay, here we're using this granularity, so this is a country specific value, or we have an assumption for a more global value. And finally, any notes or flags. So this could be whether you had chosen between two different sources and you picked that the value that you chose, or if you have already cross-checked it, or for example, in the hydro row example, we have like, oh, excludes small hydro below 1 megawatt. And these are the kinds of things that the documentation will include, because then if a country specialist is reviewing the result and it makes no sense, then if he sees that data collection, then we can figure out like, oh, okay, that makes more sense because then it's not considering this aspect. This recommendation in yellow, just like a reminder to try and do this, like I said, like sort of methodically, and not leaving things blank in the middle, because then it just might become harder then to continue the exercise. So try and go sort of like one by one. There we go. With data availability, there can be like a lot of difficulties, especially depending on which region or which country you're trying to find them. So like I said, we can do regional proxies. For example, for the GMPA, we have used like quite a lot of regional approximations when data is not available. And this can be a sufficient first step to start getting to more accuracy or different products, or get into conversations where we can engage these experts and improve the data. So yeah, it's just very important to keep in mind and to flag what these assumptions are for each of the assets. I have an example here that you can go back into for that sub-Saharan Africa regional averages. But yeah, again, to emphasize, this ongoing development of trying to engage experts and get better data is precisely because of this importance of the usefulness of the results to get to achieve the goals and to make the model more useful. Okay. So part two, I'm going to go into asset naming. Just a reminder, and because this is sort of Stephen focus and for reference later. Each asset, in different models, you're going to find different abbreviations or different conventions of how people sort of name assets. We've documented what we have for Stevens here. But the idea in our structure is that every asset technology, so like here you see for the batteries that are in the code or the source directory, we have a parameters.csv file. Every single asset that you see, we're going to have this file, and this is where all of the techno-economic data will be. There might also have a folder that says profiles, and that's for those assets that need a profile, like demand, like renewable energy capacity factors, and so on and so forth. So depending on the type of asset, you might have those too, but that's the key data inputs for assets themselves. This is for reference for you later, so I'm not going to go into every single thing, but we have the Stevens asset name and the technology description. The one thing to note over here is we currently have developed 10 brands, let's say, or like 10 bins of onshore and offshore wind each. This comes from the data collection efforts that our partners have done, which sort of separates the wind capacity factors and the costs depending on like within the region or within the country, what the levelized cost of electricity is for like an onshore or offshore wind farm. This helps a little bit with not trying to make like just an average assumption, because that underestimate or overestimate how much wind you actually have. So we try to make this a little bit more accurate by adding these, but they're just like onshore wind technology or offshore wind technology. And there's the rest of the list. Have demands and everything. That's for reference. There we go. These are new assets that are being in production. So that's for the transport sector. So we have some vehicles and industry assets already in the main sort of repository. Okay, so now we're going to go into the examples for the power sector. Right. So we're gonna have some details of some Stevens and some GMPA specific parameters and pointers for the data. So this is going to be helpful as like a starter, but you're going to see reminders coming up of this is just a guideline. You can find sources in a very broad range. So it'll establish a general pattern of what the idea is behind going and searching for the data and all of that stuff. So like you can generalize it to other data collection efforts. And after that, we're going to show, okay, we've got the values, we've recorded the sources, then how do we go into Stevens and getting into the model so that we are ready to run that. Okay. The first parameter that I want to go into is the sizing constant. This refers to the capital expenditure or the capital cost of an asset per size of that asset, so which is why it's called the sizing constant. This should capture like the full installed costs of the asset. So a lot of the time you'll see that technology assets and everything, they have a lot of different costs within each other. They have the labor costs, they have the equipment costs, the grid connections, civil works. It might also have like a portion of insurance or something that comes up like sort of upfront. All of that total installed cost should be captured in the sizing constant. And we have some examples of units here. So there's just different units for depending on what kind of things you're modeling. So for example, for all of these, for PV, for hydro, we generally can have values of money, so US dollars per capacity installed. In Stevens, we have these magnitudes, so $1 billion per gigawatt peak. If you have storage technologies, these are for like the fuels or these carriers. So instead of being per like a unit energy, it's going to be how much mass you can store of these vectors. Or if you have these conversions of, for example, ammonia to high temperature heating or hydrogen to electricity, then we're going to have, again, over that mass unit times hour, which is like that throughput capacity that you're going to put through the equipment that's going to convert your energy between one vector to another. Some possible sources. So for renewable assets and for fossil fuel assets, we can have some very common data sets and that include like a wide range of countries. So for example, for renewable assets, we have the Renewable Power Generation Cost Report, or for fossils, we can look at these starter data kits. This is mostly for low and middle income countries, but it's a good starting point. And they also have a bit of regionalized data, so like those proxies. On the other hand, we can have more global examples that can be used for different places. This can be for emerging technologies. So we can have literature reported values, for example, for batteries. I've linked a paper over here where we have some of the values for batteries, which are costs, the discharging and charging efficiency, sort of like that, the parameters that we need for batteries. Or fossil fuel assets that maybe are not in the CCG. So if you have some data gaps from here, then we can have some data from the World Energy Outlook. Specifically, how does this look like? So this is, again, first sort of example and pointer of where you may find some costs. but it may have some gaps. So I'm gonna go and show you. There we go. Let me open this. So we have this report. The link in the slide should take you to the IRENA webpage where the report was downloaded. But I think their server is having some issues, so I can't show that today. But basically, all of the data that's reported here is also downloadable in an Excel format, which I already have in my laptop, so I can show. But here's the idea. So we have, if we go into everything that they're displaying in this report, we can see what kinds of values we're having, right? So, for example, we have capacity factor trajectories or global weighted average cost of electricity. So if we're looking for a sizing constant, we're going to look for total installed cost. So if we have here, so see figure 2.5, it says total installed cost for onshore wind and global weighted average between 2020 and 2024. So if we go down here, we're going to see the figure that they have displayed. So it's more difficult to like actually extract data from these values. We have this broken down for like the weighted average total installed cost by countries. So they've displayed here, that's 15 countries. But if we are able to download the data set, this will basically look like this. So we have this. This comes from that power generation costs. Make it a little bit bigger. This has the data for all of the tables and the figures that we were seeing in the report itself. So if you want to go and find things for onshore wind, so we were in figure, I think like 2.7. So if we go to onshore wind, it'll take us to that tab. That, by the way, each chapter tab will be able to take you back to the beginning. But then we can look for the actual data. So if we want it by country, here we have weighted average total installed costs in dollars per kilowatt. And we have the data from 2010 to 2024 for this list of countries. So this is like a good place to start, but obviously it doesn't have every single country in the world. And it has some data gaps historically, but you can find the most reasonable data if you're looking, for example, to say at Mexico. Here we have it. So the most recent one would be this value for 2022. So that's where you would go and record this, convert it to the relevant units, etc., for the data collection effort. So this is one of the versions where you can go sort of back and forth between these analyses and assumptions and more detail that comes from the report. You can go and find the specific values of things that might not be included here. Okay, so that's first of all. Let me go back to display. Cool. On the other hand, for other assets, you may come into sizing constants for power plants, for example, in the climate compatible growth starter data kits. These include a lot of sort of like already collected data from many countries. You'll see in the map here what their effort has covered of these LMICs. If you go to this website and you go down to the table, you have listed all of the countries that they have collected for, and you have energy data and you have transport data. We're going to look into this a little bit tomorrow. But when you go into energy data, then you can go into table 2 and look for capital cost. So just to quickly show you roughly how that looks like. So this is the website. And when you click on the energy data, then it'll take you to this side where you can download all of the data that Osmosis will use from the starter data kits, and you can go find the files. I think for the sizing constant, yeah, we need to go to table 2, which I've downloaded here. And here I've filtered it. This is operational life. We're going to see that a little bit later as well, but you have all of these values. So you can go into the capital cost and then you can see everything. So for all of these technologies, you have the capital cost. And this is in 2020 values. One point here would be useful if you have the country specific data. For example, if that IRENA report has the values for Kenya, then you could go and compare, okay, we were looking at onshore wind, and what's the value for onshore wind in this case? Is it similar? Is it not? What are the assumptions? How can we compare? And which one are we choosing if we're trying to use like consistent data sets? One of like the complications that we can find of is that some data sets will not have everything and some data sets will be able to like complete. We can try and use the same baseline for consistency, but we have to look at the assumptions behind the things that we find. Okay. Those are a couple of initial examples. This is an example of unit conversion. So just sort of like very broken down. If we have the capital cost normally in dollars per kilowatt, which is a very common unit for these, we need to convert it to a Stevens standardized unit. So we have, so $1 in per kilowatt converted to $1 billion per gigawatt. So we have sort of like the thousands are cancelled, then we confirm that the units are the ones that we want, and we get the value. So we need to divide it by 1,000, and we can do this with like any kind of energy. We have like this little example. So depending on your units and the sort of like the Stevens units that we want to collect, that's sort of like the effort that we want to have. Other assets. So things that are not currently widely used or adopted yet. The most likely situation is that you're not really going to have any country-specific data. So values in the literature for these upcoming technologies can be used as like this first approximation. So for example, and I've linked this paper here for your reference later, this research has a table where there's a lot of data on the assets and the technologies needed for that process of generating ammonia to electricity. So we have electrolyzers, we have hydrogen to ammonia, so that ammonia synthesis via Haber-Bosch process, hydrogen storage, and lithium-ion batteries. So from here, like we can get reliable enough data for these assets that are not necessarily so used that we have that data available. As a note, CCG starter data kits also give some reference ranges within this. If uncertain, maybe to like validate or confirm, but again, it's difficult to fully estimate that cost on a very like country basis if we haven't had that adoption yet. Then we have the usage constants. So the usage constants will be the operational expenditure of the asset. In the model, we are blending both the fixed and the variable costs of this part. So the fixed costs are those that remain constant every year, regardless of like what the power plant output or usage is. So this often is like the maintenance cost, the taxes, insurance, salaries, etc., that are sort of like a given constant throughout the lifetime. And the variable costs are those that depend on like fuel consumption and depend on that runtime, other consumables, etc. Some example of units, like we've seen before. That blending of this cost is a good example of those simplifications that we've been talking about. It might not give super accurate details on like exactly like those path dependence issues if we have it blended, but it also allows us to reduce the dimensionality of the problem for computational efforts. I've used a little bit of this guidance for you for like that conversion, because fixed and variable costs are in different units. So if we want to actually be able to add them, we need to do this conversion where we have like the sort of like economic side of it here per gigawatt per year, And we need to use that capacity factor of the power plant times the hours in the year so that we could get that operational that depends on how much you're using the power. Then you can be able to like have the fixed plus the variable. So you cannot just directly use the values as they are. There needs to be some unit changes for being able to blend it. Then example of the CO2 emission factor. So anything that will have emissions will need this to be able to be modeled in Stevens. Some examples of this like are all the power plants, right? So coal, natural gas, or oil, these are going to have emissions. This database is a good source to go for each of the technology. The values are going to be given in mass of CO2, so kilograms, or it can be like megagrams per terajoules of fuel consumed. So that's going to need a conversion. If you don't know specific conversions, or it might not be like just by 1,000 ranges, you can always look up exactly like how much gigawatts are in a terajoule or vice versa, and so on, and specify the unit conversion. Next, lifespan. So that's the operational life of the assets. I've linked here as well, like a data set. So similar to what we've been seeing with the other examples, you can find the data there and see like what the latest update is and filter or find the specific technology that you want, filter by technical lifetime. And then you can see how many years there are. In Stevens, we do have to present that by hours. So you just need to multiply that by 8,760. So like all the hours in a year. Another possible source for this is going back to that CCG starter data kit. So this will be the same table that we saw earlier, and we can filter by operational lifetime, and we can filter all of the data that we have there. So it's good to like go and maybe explore and see what kind of data is available in each data set. That would be like a good exercise to understand like, okay, this is where we can gather this. And if there's not for a specific country, okay, then you sort of like deploy a different strategy for that specific country. So in summary, any additional asset parameters, the idea is to understand what asset parameters are required from the input files. And what's that's the first step to identify any data needs. Then you can go ahead and search for official reports. You can, for the parameters that I've shown as examples, you can use that as a guidance. But there's like many other institutions. There's IEA, IRENA we've mentioned, and resources that are open and accessible. So we can identify what source sort of like encompasses the data needs that we've identified in step one. Identify the source units, converts if needed. And then we have like the values with their unit conversion if they have it, the source with the table, year, page, or any details that help you find it easier for tracking. And once all of that is ready, then you can input that into Stevens or the model that you're working with if you're working with something different. Okay, so we've collected some of this data, then how do we go into Stevens? And we started looking into the structure a little bit yesterday, but as a refresher and to sort of like link everything together. In Stevens repository, we'll go into the relevant parameter CSV files. These are the directories where things are found. So for example, in code, you go into assets folder, you go into the asset, and you go into the parameters file. That will contain one row per brand or type of the asset. So this will look like this, like we saw yesterday. So this is for a renewable PV. We have that type of the asset, and we have all of the parameters related to each of them, each country in each of the rows. So in this example, for example, I've highlighted this for the United Arab Emirates. And if we want to collect or update data for this, then we have to go and find data for this country or a proxy. In a fossil power plant, we have the sizing constant, we have the usage constant. There's a second usage constant. This, I've added a note here. This was created to test and see if the model could handle quadratic costs. So that's why this is a zero value now, but this is something that is the model is capable of doing. You have the lifespan. So like I mentioned, this is a value in hours. So this will be the years converted into hours. And then we have the CO2 emissions factor. So because we have this power plant that emits, then we need to have these emissions here. So with the thing, like how Stevens communicates within files for the user input, and so you can know how to design your case study. We have that asset type column, just a reminder. So we know that this is asset number 13 for PV open field at least. And when we go and build the asset parameters, which has that structure of the network structure, first of all. So these first four columns tell us like where things are located. And then we have that, okay, PV open field, which is this asset, is an asset type 13. Then the column for type is going to have that value. So if a little bit of just like tips on troubleshooting if things are like not adding up, or if you see some results that is like weird, if you had a, let's say like a maximum capacity of a smaller maximum capacity and you see that the model has installed more, then it might be sort of like these input issues. This is currently still a bit of a manual process to do. So like we've collected the data, we have the tracked sources and everything in a single place. And then now it's like, okay, let me go and put it into Stevens and then figure out that my case study has the correct parameters to use. So I've included this as like a reminder and guidance and refresher on what these files are and how to link between them. So that when you like work or are looking at Stevens and working on your assignments and stuff, you can troubleshoot if need be with this in mind. But yeah, does this make sense? Because I think, yeah, at this point we would go into the assignment. Are there any questions or concerns up to here? No, I don't think so. Okay, cool. Let me stop sharing. Yeah, okay. Chats, all is good. Okay. If there are no questions until now, and Nick, could I ask your help to go over the assignment, please?
Yep, I'll go over the assignment. Monica, before you head off, could you send
Yes.
me the full slides, and can you send me the template, data collection template?
Yes.
So and then for the rest of them, like, do they have access to the slides in the folder, or where is it? Are you gonna send them later, or
Yeah, I believe Indira will update it later in the folder that students have access. Yeah, cool.
Okay.
So
And the data collection
I'll
templates
send
will also
this.
be in the same folder, is it?
Yeah, or I can send it as well, like to everyone. Let me quickly. Data collection template is a simple one, but yeah, let me just
You
send you
can send
this.
just the slides and data collection template to me, then at least like have it in case there are questions.
Yeah, perfect. Data.
Will I start sharing my screen?
Yeah. Okay. Yeah, I've sent you the full slide deck and the data collection template.
Okay. We're just turn on
On Slack.
Slack. Stop sharing first. Um, Yes, I have them now. Okay,
You
thanks.
said there.
Thank you, Monica.
Okay, cool. Thank you. Thank you, everybody. Yeah, I'll send the update on emails and everything, and just feel free to reach out if anything. Thank you
Bye,
very
Monica.
much.
And tell everyone I said hi.
I will do. Thank you, Nick.
There in spirit. Right. Bye, Monica. Okay. Right, everyone, can you see my slides?
Yes, it's quite clear.
Okay, thanks. Okay, so now that Monica has gone through like how to collect data, where we go in, and how to update the information in the Stevens model, let's go through the assignment. So the whole idea of the assignment is we will do three things. Number one, we will collect some data. We will input it into the shared template and stuff, and then if necessary, we update the Stevens files themselves. And then you guys can like run the Stevens files and play around with it. But the most important thing is like you're able to collect the data, put into the template with all the sources and every specifications and stuff, and any kind of like comments that you found that, oh, I couldn't find this information, so I use this year's data. And then go into these Stevens folders, update the input files. If you're able to run it, that's a bonus. If you're having trouble running it, it's still okay. As long as you guys are able to collect the data and put it into the Stevens folders, that's the main thing we're looking for. Um, so what we want to do is basically for the countries and the case studies that you've already prepared in the previous uh, lecture assignment, you basically pick two types of maybe like fossil fuel power plants, maybe for example, like open field PV or onshore wind. It could be a power plant. So basically, like a few types of assets. And then those are the kind of assets that you're going to play around with. You could choose batteries, you could choose wind, you could choose like natural gas power plant. So have a look. Just be creative about this. Once you've done that, what you need to do is like, oh wait, hold on. Yeah, so the idea is like you go on to all the different websites, collect the data as necessary, put into the template, and with the template, put all the sources and whatever is necessary. And the next part, which is updating the Siemens asset models, that comes here. So when you're updating your case study, firstly, make sure that the asset that you're updating actually exists. If it doesn't, add that asset into the case study and then like make the updates. Ensure that you are actually like connecting to the right asset number. So if you created a new asset type, so the new brand is, let's say, brand number 5. Make sure that in your case study, it's also like brand number 5. If not, like you're not using the right brand. So the next thing we want to play around, so to kind of like know that you've done something not right, is create two scenarios. One for the original data and then one for like the data that you've collected. One for the data that you've collected and one for some kind of like a change in the baseline that we want to play around with. So the first data is just we collected it from, for example, IRENA data for Philippines. We took the data from IRENA for Philippines, we put it inside. That's scenario number 1. So that's your baseline. That's scenario number 1. The next thing we want to do is we will create another brand, which would be slightly different, and that would be scenario number 2. So what we want to do with that scenario is, hold on, if I can, look at the guidance. Okay, yeah. So if any of you all want to think about like electricity demand data or renewable supply data, that would have a bit more technicalities because it's not just one or two numbers; it's a time profile. So for that, the guidance will be in the next lecture. So maybe avoid those ones right now. Try to find the other ones. So maybe, or if you do go for renewables, don't necessarily like go and find the profiles. Just find the parameters for capex, opex, those kind of things, lifetimes, and so on and so forth. For the two scenarios that you've chosen, the kind of changes from the baseline you can think about is, for example, what if I have a scenario with business as usual and another scenario where my renewables become much, much cheaper? Okay, so maybe it's a projected scenario. What if renewables were half the price? right? Then what happens? Do they start getting used? Or what if one of the renewables, what if like offshore wind became half the price? Does it suddenly become used? Maybe the business as usual scenario, it doesn't get used, but if the price is halved and it starts getting used. Or the other way around. What if like certain things are not as cheap as we thought it would be? Something happens like the supply chain disruptions, and then the cost of PV skyrockets, it becomes double. Maybe the supply chains that are coming from China, there's lots of restrictions, and then basically something like that happens, right? Then what happens? Does the model switch? Does the optimal strategy switch? What about batteries? Let's say right now, what if the cost of batteries becomes half, or the efficiency of a battery changes? What if some new novel type of batteries come about that have lower losses? So instead of 95% efficiency, they start getting like 99% efficiency. Like this really interesting batteries that pop up. Or maybe these new batteries are a bit more expensive, but they're more efficient. Then what happens? So you can then run the model and you can see, hey, do these new type of batteries start getting used? If battery prices were able to go down, do they start now getting used? If your model had hydrogen, then what if the cost of hydrogen is halved? Or what if the efficiency of hydrogen is increased? Maybe right now hydrogen is too expensive to be used, but if the cost of hydrogen became half, maybe it starts getting used. Maybe it became a quarter, then it starts getting used. At what point does it start getting used? So these are interesting kind of like policy questions you can ask yourself, and then you can implement them here by changing some of those parameters, whether it's like the efficiency parameters, capex parameters, opex parameters. So play around with them, run the model, see the results, and trying to get some insights out of this. That's the whole idea of the exercise. So the concrete deliverables that we need from this is we need what do you call it? An Excel file. So follow the template. So Monica has already given a template, or she will pass you a template with the input values, sources, and notes. So go through the template, whatever data conversions need to happen, just fill in all the columns that are necessary. If you see any data gaps and stuff, put those in the notes. If you are doing some pre-processing, for example, you found a data gap, but instead of using a previous year's, like data from 2 years ago, what you decide is, hey, actually, I could do a projection to today. Or I can say, hey, I know that the trend was that the cost was becoming half every 5 years. So I can just follow that trend. And given that trend, I know 2 years later, the cost today should be this much. So if you've estimated it that way, put those in the notes. So put those kind of information inside. Or for example, like if you couldn't find it for a specific country, you found it for a specific region, write down, oh, I could not find it for Malaysia, but I found the next best thing. I found this like regional ASEAN level thing, or a Southeast Asia level thing. So I'm using that. Or I'm using a proxy data. Oh, I couldn't find it for what do you call it, certain parts of Malaysia, but actually, there's a nearby area in the same island. We have some data for Brunei, and then we're going to put in some of the Brunei data inside. So it could be that. So put that in the notes. So just as long as like we can explain what you have done, that's the really important part. The important thing is about transparency. And just explain what your thinking is, because this is what's going to be like the most important thing. When someone when someone goes down the rabbit hole, the important thing is not as much of like, is this the correct thing to do? Because there are a lot of right answers. The important thing is like, write down all of your thinking as much as you can. What was the process that you went through? What was going through your head? Why did you pick a specific type of data, right? Why was this the best thing you could get? And the whole idea is that this will never be perfect. And in the large scheme of things, if you realize there's so much data being collected, there's so much uncertainty. We're thinking about the future 50 years. So the important thing is not necessarily getting it right, because you will be wrong. A lot of uncertainties are there. The important thing is about transparency. It's about making your assumptions known. And if someone says, hey, actually, I want a different assumption, the idea is you can just quickly go in and change it, right? And if someone asks, what were your assumptions? You just explain, these were my assumptions. So it's about building that confidence from transparency. That's the main idea. So don't focus too much on like, I need to get the best data. Focus on like, I need to get a data. It's reasonable. It's explainable. It's justifiable. I can explain why I picked this data, and write the explanation down. The next part is like, once you're able to do this, put those information inside the Stevens model. So update the asset parameter file in Stevens. And if you were able to run the Stevens model, run them again. create those two scenarios, one from the actual raw data that you collected, the other one from the new scenario that you created, which is like take those parameters, modify them, like, a third of the energy or like a third of the cost or something like that. Run those models, get some plots, document them, have a think about like, oh, I actually did these things. Like I ran these two things, and these are the kind of results that I got. If you're unable to set up the models, it's fine. Just the Excel files are fine. Just put them into the Stevens format. So you have the Excel files, you have the Stevens input files, and then you have some results that you plotted, right? When you run the model, it comes up with some plots, just save those plots. If you're able to run it, save the plots. If you're not able to run it, just have the data collection template, have the Stevens input files, and if you're able to get the results, get the results. These are the three things you want: Excel file, the input files for Stevens, as well as the output files from Stevens. So the plots. So this will be your deliverables and your final assignment for today. Questions about this? Well, what we need to do? Okay, so if not, then I have questions for you guys. Um, so, oh, okay, Christine, go on.
Hi, good evening. I'm Crispin from the Philippines. I hope I am audible.
Yes,
Okay.
we can hear
So
you.
my question is, you have more examples about this the scenario. I mean on the
The
next slide.
scenario.
Yes.
The scenario, right?
Yes. Does it have
Okay,
to be
so let
collected from the assignment one? Or it's a separate how do I say this? It's a separate scenario.
um so in assignment one, you've already created something, right? So these are Stevens files. Remind me again, the assignment one. Did you end up getting Stevens files?
Yeah. Yeah, I remember.
Yeah. So you got some Stevens files, so you have the case studies. So from there, pick one of the assets that are inside your case study. So let's see. Let me show you what it might look like. So let's say you created your case study. And your network structure had these assets, right? So from these assets, have a think about like, okay, you know what? I want to try and gather data for, let's say, two things, just batteries and you know what? Ammonia storage. So ammonia storage power plants. So or ammonia storage tanks. So I want to go and find some data for this. Uh, once we know we want to find this, what we then do is we go up, not here, sorry. So here we go to the assets. We go to battery, so BESS. There you go. Open up parameters, and then you would find that for the parameters, these are the types of parameters that we need to go and look for. Okay? So we have things like, for example, this sizing constant, conversion factor, and so on and so forth, right? So this will be in the data collection template. So in the data collection template, that's like the raw data you gather. Do any kind of conversions you need to do, and then fill this in, right? So what you would do is, if you created a new brand, you would copy this. Like basically, you would have like 31, right? Like you make a new row, you add a new brand, and then maybe this one is not for Japan. This one is for like, I don't know, some other country, like some country XY, right? Doesn't really exist. So that's why hopefully it won't break anything. So that's kind of like, imagine this is your raw data. Then this is scenario number one. This is like your baseline. And in scenario number two, what you would want to use, for example, is I will want to use this, and then I would have another version. So this is 32, and this is I have XY or XZ or something, right? So then I would go back to here. This is the structure. Don't say this. So I had a scenario. In the current scenario, my asset parameters, I'm using BSS asset type number 1, right? So what I would do is I would now that I've created this, I can create a scenario. I can create a copy of the scenario. So scenario number 0, this is where I keep the new data that I gathered for battery. So that was 31, right? So now it's going to pick from 31. So that's the base scenario. Then the new scenario would be, if I go back, this is my other scenario, scenario number 2. I go here, I can go to these assets, and the type that I'm looking for now would be the battery, but this one will be 32. Okay, so now scenario number 1 and scenario number 2 point towards 2 different batteries. Scenario number 1 points towards battery number 1. Scenario number 2 points towards here. Now, battery number 1 is the original data that we gathered from IRENA or wherever. The type of brand for battery number 2, for this one, what we do is we say, hey, now let's assume that this new type of battery is maybe the cost is halved, or maybe it's like 0.1 12 instead of 0.27 or something like that. So this is a much cheaper battery. Then what happens? So when you run Stevens, now you run 2 scenarios, you'll get 2 results. In one of the results, batteries are normal priced. In another of the results, batteries are half the price. So when batteries become half the price, what happens, right? Do things change? Or maybe right now what you find is in the base scenario, when you run it, batteries are already getting used. So obviously, this is not an interesting scenario to test. If batteries are already getting used, half the price, they still get used. So what you might want to do instead is you go to the ammonia storage. And then you go, hey, what if my ammonia storage, one of my H3, so maybe in ammonia storage. Okay, so now I have a cheaper type of ammonia. Then maybe in scenario number 1, in the business as usual, it picks using a battery. The results end up choosing that, hey, you start building some batteries. But in scenario number 2, when you're picking between what do you call it, some ammonia storage that is half the price of what it used to be, then it starts choosing ammonia storage instead of batteries. So then it's sort of like what do you expect, right? If ammonia storage becomes cheaper, then ideally the system tries to use that instead of batteries. And you can then go loose. Instead of cost, you can think about efficiency. So right now there's some losses in ammonia. So the storage losses are very small, but maybe the electricity to ammonia conversion. So that could be something that you want to change, right? So if you have where's this? Electricity to ammonia. So that's your electrolyzers and stuff. Yeah, electrolysis and hyper wash process. So it's a combined thing. So maybe that's where you want to do. Like you have a new type of technology that isn't really cheaper, but the efficiency, the conversion of like tons of ammonia to amount of energy, amount of electricity. Oh, it's actually more efficient. So it can do like, uh, yeah, it can produce more. Oh no, actually, this should be less, 0.05. So it requires less ammonia per electricity. Or oh no, sorry. Yeah, that was correct. 2.15. So you can produce more ammonia for the same amount of electricity. So you say, hey, look, now we have another process. Someone came up with some new type of electrolyzers and so on and so forth that are able to produce ammonia and hydrogen much more efficiently with less energy. But the price is about the same. Then what happens? Does that change a thing? Perhaps even becoming more efficient is not worth it. Those are some interesting insights that could come up. So you can play around with these kind of things. Right, so I'll stop there. Any other questions? Okay, bye, Shania. Hi, Anik. Do we do the scenario? Do we compare using the same country or can we use different countries? Okay. So try to keep one thing the same. So you can play around with different countries as well. So you can have like um ideally you change one thing at a time. So if you're changing a country and then also changing like the type of um let's say battery cost and stuff, you may not be able to see the difference. Um Or if you are running two countries, that's also fine. Like in two countries, one of them has no, they both have different price of PV. That could be something, some way you're dealing with the scenarios. That's also okay. You can also do that. Um, but ideally, pick a country or pick a scenario or pick a combination of countries, change a few of the data, rerun the models so that you can compare what happens. If not, like if you make too many changes at once, you can't tell why the change happened. Any other questions? So I guess the main thing is that it's a process of gathering the data. Where do you need to go? And the main difficulties you guys will face is messy data, missing data. The units are all over the place. And what do they mean? That's going to be the biggest challenge. And going from what's on the web, try to use the sources that Monica has sent to what needs to be in the template. And then after it's in the template, put it into the Steven scenario files. Um, so this part is the one that is going to be the most difficult bits. Uh, the last part, when you actually finally like run the scenarios and have fun, that's kind of like the goodies, the results that you get, right? Like for all their hard work and labor. So this is the motivation. The motivation is that you are able to do some kind of interesting policy scenario analysis. Um, cool. Right. If there's no other questions, then yeah, I think we can end the conversation from today. Indira, do you want to say anything or
Yeah, thank you, Anik, for providing the description about the exercise, and I will also upload this by tomorrow as I received the file from Monica. And just to inform everyone that I have also uploaded the recording from the first day until yesterday, and also will upload the today's records tomorrow. So everyone, please, you're welcome if you have any questions through email, um, just let us know. So I hope this session would be insightful. See you tomorrow for the last day. Thank you, everyone.
all right, thank you everyone. See you guys tomorrow.